to lesson 3.5 on equations, tables, and graphs. We're going to see how all these things are related to each other and how we can use them, okay? So a table can show how two things are connected to each other. You can write an equation to show this relationship. Here's an example. You save $3 each week. Make a table and then write an equation to show the total savings after a given week. So here's my table that I made. Here I have number of weeks, and I wrote 0, 1, 2, 3, and then W, which is going to stand for any type of week. And then here we have the total savings, and then this is going to stand for our expression. So, for example, if I had in 0 weeks, my expression would be 3, because it's $3 times 0 weeks. And so that would mean that I made a total of $0. Well, in 1 week, I would make $3 for that 1 week. And so I would have made $3 of savings. In 2 weeks, times $3 a week, I would make $6 of savings. In 3 weeks, and you get how this goes, I would have made $9 of savings. And then this W I can put in, just like I've been putting in all these other numbers, to represent any number. So if I said, how about in 9 weeks, then I would replace the W with a 9 and do 3 times 9 is 27. And so whatever we get, we're going to call the T for total. Now I can take this information and I can write it as an equation. So I'm going to be looking for what relationship this column has to this column. This is showing how they're connected. So my equation would be T equals the total savings equals the number of weeks times 3. So 3W. That's my equation right there. Now the next thing that can happen is I can be given an ordered pair, and we can find out whether or not that ordered pair is a solution of the equation. So here's example 2. Any ordered pair that makes an equation true is a solution. So the example is each ordered pair a solution of the equation y equals 3 times x? And then I have here an ordered pair. And remember that an ordered pair is written as x and then y. So my 2 is my x and my 6 is my y. And I'm just going to replace it into my equation right here. So I have y equals 3x. I'm going to replace my 6 for y because it's in the y position. And I'm going to replace my 2 for x because it's in the x position. And then I'm going to see if it's true. 3 times 2 is 6. So does 6 equal 6? It does. So therefore, my answer is yes. 2, 6 is a solution of the equation y equals 3x. Okay? If I look at this second problem, I'm going to do the exact same thing. I have y equals 3x. I always start with my equation. And then I'm going to plug in my negative 2 for x. And my y is a 4. So 3 times negative 2 is negative 6. Does 4 equal negative 6? Well, no, it does not. And so my answer would be no, this is not a solution of the equation y equals 3x. It is that simple. Okay? If you can plot all of the solutions on a line, it is called a linear equation. So a linear equation means that when you come up with ordered pairs for this and you plot them on a graph, they'll all form a line. Here's an example. So the example, graph the equation y equals negative 1/2 x plus 12. Now there are 2 different ways to graph an equation. One way is the first way, and this is what's actually talked about in your book in this lesson, and we're going to do that first. And then there's a second way, because this is written in something called slope-intercept form. Okay, and we're going to talk about that next for kind of a shortcut to graphing. But here we go. Here's the first way that you need to know how to do. So step one is to make a table. So here's my X, and I'm just going to pick different numbers to use for that. Most commonly, we use the numbers -2, -1, 0, 1, 2. Although in this case, the book and the example, they gave us 0, 4, and 8. So I'm going to use those examples. Those are those numbers. And then my Y, we're going to figure out. And we're going to figure it out by dropping this X into our equation and filling it in here and seeing what it spits out. This is kind of like a function, or it's not kind of, it is a function. So we're dropping in the value of X in for this X, and we're seeing when we solve it what Y would be equal to. So if I dropped a 0 into X here, then I would have it, and you could write that here, or I'm going to write it off to the side for right now. So I have Y equals 1/2 times 0 plus 12. 1/2 times 0 is 0 plus 12 means that Y equals 12 for X is 0. Okay, what about if X equaled 4? So I'll do Y equals -1/2 times 4 plus 12. So -1/2 times 4 is -2, and -2 plus 12 is +10. What about if X was 8? Well, Y equals -1/2 times 8 plus 12. -1/2 times 8 is +4, is -4, and -4 plus 12 is +8. So what I have done here is I've actually given myself some ordered pairs because this is X and this is Y. So if I were to write this as an ordered pair, I would write 0, 12. This one would become 4, 10. This one would become 8, 8. And now I can take those ordered pairs that I have and I can do what we have figured out how to do. And we're going to graph them by plot the ordered pairs. So here I have my graph. And because with these ordered pairs that I had, they were all positive numbers, I'm going to make this only in quadrant 1. So this would be 1, this would be 1, 2, 3, 4 going all the way up, and 1, 2, 3, 4 going all the way up. They're all positive numbers. So my first ordered pair that I had was 0, 12. So 0 means it's going to be right here on the y-axis because I'm not going to run it all, and I'm going to come up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Woo! Okay, my next one is 4, 10. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The next one is 8, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And now I can take a ruler and I can connect all of those dots to show my plotted line. Draw arrows on it. And this line equals y equals -1/2 x plus 12. That's what this line is. So now I want to show you kind of something cool about this that isn't in this lesson but is kind of a shortcut for understanding lines. When equations are written this way in y-intercept form or slope-intercept form, then we can use these numbers. It's kind of a little trick. This 12 right here stands for where the line will cross the y-axis. It's called the y-intercept. So notice this says plus 12, and that's where we crossed the y-axis, was at positive 12. And from that point, this is my slope. This is how much we're going to rise, and it's over the run. So I'm rising -1, which means I'm dropping -1, and then I'm running 2 spaces, 1, 2. And every time I do that, I'm going to make a new point on the line. I drop 1, run 2, drop 1, run 2, drop 1, run 2. And notice, drop 1, run 2, I'm back on this line. And I could actually continue this line by following that all the way across. I can reverse it, and instead of making the -1 up here, if I put my negative down here, I could rise +1 and then run -2. Rise +1, run -2. Rise +1, run -2. So this video has become kind of long, but I want to show you with one more equation how you could draw a line just straight from this without even making the table. So let's say that we had a line at y equals 2x plus 2. So for this equation, I'm going to want to make my 2 into a fraction by putting it over 1, because slope, we always want to rise over a run. I'm going to start by looking at this, my y-intercept, and I'm going to make a point where at this number on my y-intercept. So 1, 2. This is where my line would cross the y-intercept. Then I'm going to use my slope to draw the other points. I'm going to rise 2 and run +1. Rise +2, run +1. So rising 1, 2, running 1. Rising 2, running 1. Rising 2, running 1. Rising 2, running 1. And then I could connect those with a ruler. And now I have graphed this line. So both ways are correct. There was a lot of information in this lesson, and I hope that you feel prepared to use some of it. Go ahead and try out your odds practice problems. Bring them in with you on Monday, and we'll go over some sample problems. Go ahead and get to work.